Hi, welcome to this video, another in my series on the locus of a complex number z. Now, in this particular video, what I'm going to look at is the arg of z minus z1 equaling theta. And if I take my Argand diagram here with the real axis and the imaginary axis, then let's say we have a general complex number z. Okay, we'll just mark that in as being z. And at the end here, let's say that this point here is, say, P. Okay, let's just mark that in as P. And Z1 is, say, a fixed point. Let's say that this is the complex number Z1. Just mark that in as Z1. And the endpoint here, let's call that A. So that's A. So if I was to consider A to P and think of this as a vector, then A to P would be minus Z1 plus Z, or in other words, Z minus Z1. So this represents the complex number Z minus Z1. And when we talk about the arg of z minus z1 equaling theta, then what we're saying is that if we were to draw a horizontal line across here from A, then this angle in here would be theta. So what we've got here, if z can move from A outwards, okay, it will move along this red line here, and if we extend it, okay, let's just push it up to there, z could be anywhere on this line from A going beyond P. And we call this a half line. So we say that if z satisfies this equation here, the arg of z minus z1 equals theta, then this represents a half line from the fixed point z1, making an angle theta with a line from the fixed point z1 parallel to the real axis. Now we must remember that theta must be an angle always then between minus pi radians, but it can be less than or equal to pi radians. So when we're drawing these half lines, there's several scenarios that we could get. I'll just illustrate a few. Okay, I won't mark on the real axis and the imaginary axis here because I'm a bit short of space, but just to give you an idea, we could say have a half line, say from this point here, this is our fixed point where Z1 is, and it could be that theta is, say, 3/4 pi. That would be an angle out here, okay? The line would go from there. If I was to draw a dotted line in there, this would be theta, okay? It might be that theta is a negative angle, all right? And Z1 could be, say, at this point here, and if theta were, say, minus 3/4 pi, then we'd have a line going in this direction. Because if I was to draw a dotted line from here, this would be our angle theta. So several situations that you can have in these types of diagrams, okay? Now I've got an example here that I would definitely encourage you to have a look at because it throws up some different ideas. We've got to sketch the locus of z for which the arg of z minus 3 plus 2i equals minus 3 pi over 4, and also find the Cartesian equation. Now if you feel that you'd like to give this a go, just pause the video, come back when ready, and you can check your work solution with mine. Okay, welcome back if you had a go. Well, first of all, what we've got to do is to be able to write this, first of all, in this particular format. And it's only a minor change that we need to do. We've done this in the past in other loci type questions. We just need to write this as the arg of z minus, and then we just put this in brackets. We change this to 3 minus 2i. Okay, so that it falls out, giving us exactly the same result as this. And this equals minus 3 pi upon 4 radians. So we've got this now in this particular format. So that means that what we've got is that z1 is this complex number 3 minus 2i. So we've got a point on the Argand diagram with coordinates 3 minus 2. And we've got a half line going at an angle of minus 3 pi upon 4 to the positive real axis. So what that looks like, if we were to sketch it, let's just put our imaginary axis up through here. Just label that imaginary axis, IM. And we've got a real axis, so just put that across there. Real axis, and if we go to the point 3 minus 2, 3 across, 2 down, let's just say it's this point here, mark that in as 3 minus 2. Then at this point here we've got our half line going at an angle of minus 3 pi over 4 radians. So in other words, if I was to draw a dotted line across here, this angle in here, let's call it theta, is equal to 3 pi upon 4 radians. Remember, it'd be a negative angle because we're turning in the clockwise sense, and that angle had to be in this range here. So the complex number z from the origin here, let's just mark that in as the origin, the complex number z would be out to any point along this line here, this half line. So let's just suppose that is one of the many positions that z could take up. Okay, so there's our sketch of our half line. Now it says find the Cartesian equation of this half line. And this is where we've got to be very careful. Now, let's just take this point here, P, say, and we'll say it has, in general, coordinates x and y. It's going to vary as z moves along this half line. So in other words, let's say that let z be the complex number x plus iy. This is the general way that we work with the Cartesian equation type of question. And for this question, it just means that therefore we've got the arg of, instead of z, we're just going to write x plus iy. And then we've got minus 3 minus 2i, okay, equals minus 3 pi upon 4. Now, I'm going to group together the real and imaginary parts. So therefore we've got the arg of, and then the real parts will be x minus 3. Let's just put that in brackets there. X minus 3. Then we'll put plus I, pull out an I as a common factor, and we've got y plus 2. Okay, y plus 2. And that is going to equal the minus 3 pi upon 4. Now all we need to do now is say that the tangent, or tan, of minus 3 pi upon 4 radians would equal the imaginary part, y plus 2, divided by the real part, x minus 3. Now the tangent of minus 3 pi upon 4 radians is 1. So therefore what we've got is that 1 equals y plus 2 over x minus 3. And if I multiply both sides by x minus 3, it follows that x minus 3 must be equal to y plus 2. And if I rearrange this, just let's say we make y the subject, we subtract 2 in other words then from both sides, we therefore end up with y equaling x minus 5. Now this is where we've got to be very careful in these kind of questions, because we've got y equals x minus 5, and y equals x minus 5 would be a line like this, okay? It wouldn't be a half line. So what we need is this portion of the whole line, y equals x minus 5. So it's only valid for x being less than 3. So just put that in here, for x being less than 3. And it's at this point where care has got to be taken in answering questions like this. Okay, well, that brings us now to the end of this particular video, and I hope it's given you some insight into how we can handle this equation, okay, and that you'll be able to model any other examples on this particular example here. Alright, okay, so good luck with those questions.